for our next chapter 3 problem, we're going to take the equation in standard form, x squared plus 4x plus 1, and convert it to vertex form with the intent to graph it. Alright, first thing that I want to point out is that it doesn't factor, because there are no factors of 1 that combine to 4. So we can't really factor and plot the x coordinates. So another difference between this and a previous completing the square problem that I've done is that this is not equal to 0. We are not solving for x using completing the square. We are converting it to a particular form, which means that we have to kind of play all on one side. So I'm going to say that f of x is equal to x squared plus 4x, and then I'm going to leave some room, plus 1. I'm going to kind of group these together. Now I'm going to complete the square within this group of parentheses. So half the middle term is 2. 2 squared is 4, plus 4. So if this were an equation and I were dealing with the other side of the equation, what you do to one side of the equation you must do to the other, I would have to add 4 over here. But since we're staying on the same side, where I add 4 here, I must subtract 4 outside. This can also be complicated in a different type of problem where there's a number out front. That 4 we just created would have to be multiplied by a number in front in order to get the number outside, in order for it to properly balance. The goal here is to fundamentally not change the equation. Everything we do leaves it the same way that it was when we started. The 4 and minus 4, they would cancel out to nothing, and we'd be left with what we started with. So this term here is a perfect square by design. So it's going to become x plus half that middle term always. You don't even have to bother factoring. It's always going to be half that middle term. Half that middle term is 2 squared, and then negative 4 and 1 is going to be negative 3. So this is vertex form. Okay, vertex form, for those who don't recall, is f of x equals a times x minus h squared plus k, where h and k are the vertex. A is your scaling factor, which you get from the standard form as well. Well, here, if negative h is the coordinate, our vertex is going to be at negative 2. And our y-coordinate of the vertex is negative 3. So I go over to negative 2, and then I drop down to negative 3, and that is my vertex. Now, parabolas, so long as they don't have that scaling coefficient, are fairly easy to draw. First, I can sketch in my axis of symmetry. That's everything will fold around this line. It always occurs at the vertex. Now, for every parabola, you go over 1, up 1. And because it's symmetric, I can go over 1, up 1 negatively too. Now, I can go over 2, up the square of 2. So that's over 2, up 4. So over 1, 2, up 1, 2, 3, 4. And that's at 1, which is my y-intercept. So I'm on the right track here. So line of symmetry, I'm going to go over 2, up 1, and I have 5 points, which is more than sufficient to sketch a parabola. So the parabola is going to come in very steeply, then it's going to kind of pull up, and then leave us quite steeply again. So vertex at negative 2, negative 3, axis of symmetry, over 1, up 1, over 2, up 4, and all of this would be flipped if it was a negative, or it would be scaled if it was a 2 or a 3 or a 4. So know your vertex form and know how to find the vertex.